Good evening, everybody. I'm just gonna check that I'm coming on live in the right place. So give me a moment. This is all just part of the slickness that I can look at myself on Facebook. There we are. And there's a slight delay, so I'm gonna turn that down. So a very warm welcome to you. My name is Karen Wilding and I am the director of EYMaths, and this is my group that you're in. This is the main group for support for the training that I offer, and it is free to anyone to join. And I've got lots and lots of screens in front of me, so you'll have to forgive me that I will try very hard to press the right thing at the right time, but if not, we'll just go with it. Okay, we have got a lot to share tonight, so I'm going to get straight on. And I want you to know that at any point during the session tonight, you can ask me a question. This is obviously, I'm on screen, you're not here, but you can put anything you like into the chat box and we can continue these conversations on this group after tonight's mini masterclass. All right, so let's get going. Now, the first thing I'm going to tell you is hi everyone saying hello. The first thing I'm going to say is the reason I am running this session, this free mini masterclass for you tonight, is I have a membership called Impact, which many of you have heard about, particularly those of you who did the Sunflower Challenge with us. And we meet very regularly, but one of the sessions we do is a Sunday night kind of catch up where I come on just like this. And a question that was asked just over a week ago was about clarification on use of 10 frames. And it wasn't actually that the person asking didn't know, but what they were seeing was an increasing number of occasions. This person goes into many settings, nursery and reception. So in the UK, that is 3-4 and 4-5. And they were seeing 10 frames being used in a variety of ways, and ways that they felt were going to cause a lot of problems with children's calculation as they moved on through school. And they wanted to kind of bring it to the attention of, we have over 1,000 members in the group, in the Impact community, that we needed this joined up thinking and we needed to explore why. Because the main thing that I will say to you right from the start, and this is so important, is what I am aiming to do tonight is to give you the reasons why we need to teach 10 frames in a certain way. And it's not because Karen Wilding said so, and it's not because that scheme said so. It is purely based on maths subject knowledge. That is the only way to gain confidence in teaching maths at any age group. So this is not about a fad or a passing phase or new maths or anything. What I'm going to show you is the really strong, firm foundation that is maths subject knowledge that underpins why we need to do things the way we do. So I'm going to be, oh hi Margaret from Caracas. Margaret is one of my Impact members as well. So hello everyone saying hi to us. That's fantastic. So keep on saying hello and ask any questions you wish. Okay, so I'm going to go straight over to, I've got some notes to help me here. But first of all, a welcome, of course, to our mini masterclass. And, I wanted to be really strong about this and say, as I say, there is a right way to do this. There is actually more than one right way, which is going to sound strange, but those of you who know the kind of training that I share, you'll see why I'm saying that and what I'm saying as we go through here. And say some of you know this very well already. So here we are. Here is our friend, the 10 frame. And here is the 10 frames younger sibling, the 5 frame, both incredibly important mathematical tools. And I want to use that word tool because, we are not going to be able to do a lot tonight. We are going to touch on some very, very important messages and some very important teaching. But I want you to know that to learn to do this, depending on where you are in your journey, you may have to unlearn a lot of things. That certainly happened to me and happens to a lot of people I work with. But there's so much more I need to tell you than I can tell you tonight. Okay, so here are the highlights. But if you want to learn more, you need to come back and do, more extensive training. So bear that in mind because there'll be a lot of questions. So I wanted to start off with some of these things. These sorts of statements are going to cause you a lot of trouble. So We were told we had to do it this way. So that isn't based on this is the way maths works, this is what's best for the children. This is how we feel when we lack confidence and when other people come along and they have more knowledge than we do perhaps, or they think they've got more knowledge than we do, and they put us in a position where we feel we have to do what we're told instead of what is right. And that is difficult. It is really difficult, but what makes it easier is when we improve our own subject knowledge and we can then fight our corner so much better. It is, as I say, I don't deny that is a difficult situation to be in, but it's all about educating people and showing people why things work the way they do. The second one, I put my little face there because, oh my goodness, we're a mastery school, or we teach a mastery curriculum. I wouldn't want you to teach anything other than mastery, but I would want everyone to know what mastery is and that it isn't a scheme and it isn't an approach. Mastery in any part of life, or mastering, I think is a much better word personally. Mastering is making sure you have all the tools you need and you can use them really, really well. And I hope you hear the sense in that. If you want to talk another time about the mastery or mastery approach, we need to talk about Jerome Bruner. We need to talk about Singapore. And many practitioners and schools are not in a position where they can talk about where this came from and what this is about. And everything I'm going to talk to you about tonight would link really well with what Jerome Bruner advocates and therefore is connected to mastery. But make sure it's not a word that's just being bandied around. You need to know what it means. And then a big saying of mine is be a user, not a follower. So we follow whatever scheme, and this is, they do it this way. And you think, again, that's not a good reason to do something. If you are following White Rose, Maths No Problem, Power Maths, NCETM, whatever it is, you need the maths subject knowledge to know how to interpret what's being said, what is missing, how to teach what is being shown either on a PowerPoint or it could be an activity, it could be on a worksheet. You need to know, is this the best way? Is this what's going to work with these young children? Don't assume because it's a scheme that it's good. Okay, so again, be a user, not a follower. So I hope those things are helpful as well in setting the scene. So I'm going to have a look here and I'm going to come between you watching things that I'm going to do live and showing you some things on the screen. So I hope this is helpful. So someone's saying they are scheme assisted, not scheme directed. Absolutely. The only way you will ever take control over what's happening and use different resources and different ideas in a really effective way is having A, growing and improving maths subject knowledge yourself, and B, understanding the pedagogical implications for the year groups you work with. So we're working with very young children. We need to know how the brain starts to make sense of maths at the age group we're teaching, but the maths subject knowledge doesn't change regardless of the year group we work with. So that, again, is a lot to think about there. So instead of the things above here, which I have been a consultant for a very long time, a teacher for a very long time, senior leader and so forth, and I've heard phrases like this, possibly as well from myself earlier in my journey. And instead, the only question that is relevant is, what are we aiming for? What's our destination? What are we trying to give our children? So if you're watching this, and I know there's a few of you watching this that are subject leaders from Key Stage 2, so in the UK that's 7 to 11, or you might be watching this as a head teacher and you are not teaching the age group that I specialise in now, I want you to think the problems you are seeing with your children age 7 to 11 and above with their calculation and their number sense, that what we're doing here is about changing that so that we don't have those problems later on. So I'm going to show you some examples tonight. All right, so let's move down here and have a look. So these are big ideas and very important. So before we talk about 10 frames specifically, we have to think about the fact that our number system is built on the base 10 system. This wasn't always the case, but base 10 In 1971, when we moved from our imperial system to our metric system, everything except time works in base 10. And that makes learning about numbers really easy when you understand that. Now, a 10 frame shows a base 10 in what we would call a concept image. So it makes sense of why we write a 10 the way we do. And I'll show you this in an image in a moment, but you look at that 1 and that 0. That 1 means a finished group, and the 0 means none of the next group of that size yet. So we've got a predetermined size, and another way of thinking about that is the idea of unitizing. So a unit is not just the old name for ones when we think about the tens column and the ones column. A unit means a finished group of something, and it's a finished group of a predetermined size. So I'm going to come back onto the screen now. Let's move between showing you things and talking. So this is something I do a lot of in the Teaching Essential Number Sense course, and I'm going to show you a little bit of that at the end, but you can find that if you just go to my website, www.eymaths.co.uk. Under Learn with EYMaths, you will find the TENS course. TENS course, nothing to do with the number 10, it's just Teaching Essential Number Sense, just happens to be the acronym of TENS, which is very helpful, I think. All right, so here are my not very well drawn out, you'll have to forgive me, but it'll suffice for what we're doing. But here is a group of 10. Now, if I was creating, as I say, we do more of this in the course, but I could unitize in groups of 3 if I just show you for a moment, because it's about everything I'm sharing with you tonight is not about what the children understand, it's about what we understand, because when we understand it, we will then teach it really well to the children. So all of my training is about investing in you. So if I had, for example, let's take a step backwards first. If I had some counters like this, and I was unitizing into 3s, so I want to create finished groups of 3. There's a finished group of 3. There's a finished group of 3. Can you see this is the beginning of another group of 3, but it's just one of those 3. So we've got 1 finished group, 2 finished groups, and 1 of the next group. So that's what we're unitizing in there. So you can see that unitizing is to do with multiplication, and then by default, it's going to be to do with division and so forth as well. But fortunately for us, we don't work in multiple bases anymore, we just work in base 10. So a 10 frame is a finished group, and therefore we have, when we finished it, we start another one. And when I showed you that before, if I just fill this one in, you can see, and honestly, I hope you go away from a session like this with more questions than answers, because there is so much to share, but it all makes so much sense, and it's all connected, and it's great news for anybody. Some of you will have done the super subitizing challenge with me and the 1 to 10 challenge and so forth. So can you see there that that group is finished? And it's a finished group, and there's none on the next group yet, which hence why it's a 1 and a 0. If I was to do this, for example, 1 whole group and 2 of the next group. So I would write that 1 whole group, 2 of the next group. That's why 12 is written the way it is. Particularly helpful when it comes to teaching teen numbers, because we've got things like this. We always are told, and I totally disagree with this, that teen numbers are difficult. They're difficult if you teach them the words first. They're difficult if you teach them the digits first. If you teach them what it is first, a finished 10, and 4 of the next 10. So can you see there? Listen to the language as well. This is something we make a really big deal of. So when we're looking at 14, what I can see is 1 finished group, which I'm going to learn is called 10, but that's a kind of separate bit of learning. 1 finished group of 10 and 4 of the next 10. So not just 1, 10 and 4, or 4 more, but actually this is 4 of another group of 10. So the idea that we actually never need to understand numbers beyond 10, this is a big statement to make, but it's totally true, because base 10 says when you've finished, you start another one. And that's why 14 is written 1 finished group of 10 and 4 of the next 10. And you understand what it is before you write it down. and then you give it a name, and of course it's only called 14 in English. It's called all the other things it's called in all the other languages that you will speak. Don't focus on the words of what it's called, because I'm called Karen, but if I wasn't called Karen, I'd still be me. My name doesn't define me. You know, what I am, what it is, defines more than the name. So hopefully that really makes sense. If you've not come across this before, that's one of the things that we're thinking about here. All right, so teen numbers, like I say, are beyond simple parts. They are whole groups of tens and parts of the next 10. And once we go beyond 2 finished groups of 10 here, so when we get to this point, where if I was to, and don't get hung up at this stage about the way I'm filling it in, because I'm going to go back from that. I just want to start with the destination here. So you can see there we've got 1 finished group, 2 finished groups, none of the next one yet. So therefore a 2 denoting the 2 finished groups and 0 denoting none of the next one yet. So those of you working with older children, if you were to see as a child a 2 and a 0, and yes, you say 20, and maybe you think about 20 coming after 19, and there's an awful lot of learning that we need to fill in, which we're not going to talk about tonight. But if you can picture that 2 means 2 finished 10s, and you've got this concept image, which is an image in your mind of what that looks like. If I say, for example, divided by 5, and one way of interpreting 20 divided by 5 could be how many groups of 5 are in 20. It could also mean 20 shared 5 ways. So that division sign's got 2 meanings. But if we look at the how many 5s are in 20, can you see that if you saw that as a calculation and you understood what that 20 was, the idea of being able to reason that there are 4 5s in 20 becomes really easy, because you can actually see them. Well, there's 2 5s in each of the 10s. And you make that link then about why, when we're counting up in 5s, multiplied, we get to 20, and therefore 5 is a factor of 20. And when you multiply 5, 20 is a multiple of 5. So this is the same knowledge. What I'm talking about here is Key Stage 2 knowledge, but it's based on the stuff that we do in early years. It's using exactly the same tools. Okay. All right. Okay, would you show 4 in a line? Yes, I'll come to that about the arrangements in a moment. All right. The other thing we need to do, really, really big deal, is we need to see what numbers look like in relation to 10. So we need to know what a 6 looks like in relation to 10, what an 8 looks like in relation to 10, what a 2 looks like in relation to 10. And when we've got that, we can begin to add, subtract, multiply, divide, use fractions, and so forth. So again, I'll come off and share with you there what I mean. Oh, click on the right button. Okay, so, and I'm going to come to the fact that there's 2 patterns that we need to be teaching our children. I'll come back to that in a moment. But can you see there a 6? When you look at it in relation to a 10, you see what's not there yet. So you could think about a 6 as having 3 2s in it, or 2 3s in it, or a 4 and 2 more. But you can also think about it as being 4 fewer than a 10. It's a 10 with 4 missing. And when that becomes particularly useful is, can you see how similar a 6 is to an 8? Let's compare them. So imagine if these weren't on a 10 frame, even as an adult, those 2 images, sorry, it's a bit wonky, those 2 images there are very, very similar. Okay, they're sort of the appearance, if it was a little bit straighter, it'd be better, wouldn't it, aesthetically? But can you see that in relation to a 10, an 8 is when there's 2 missing, and a 6 is when there's 4 missing. And particularly then when we get to numbers like this, we can start reasoning that whatever number that is, it's 1 less than a 10. And if we add another one, it will be finished. So even before we know it's called a 9 in English, the idea that that number is the number that is a whole 10, but with 1 missing. And this number here is a whole 10 with 2 missing. And this number here is a 10 frame with hardly any on, and loads of space. So we're creating these images, but not just of the numbers anywhere, which I'm going to come to in a moment, but actually in relation to 10. Because you are not going to be able to learn to calculate if you cannot hold that image in your head. And I'll show you an example of that here as well. So imagine this is our calculation. Okay, so we've got there, you know, what do you see? That's what I'm known for, saying, what do you see? How do you see it? So there'll be a lot of knowledge, that's a lot of skill building before we got to this stage. Don't forget, I'm talking about 10 frames today, but not necessarily how to teach 10 frames, just the importance of why we teach things in a certain way. So we've got an 8 there, and we're going to add a 4. And imagine that written as a calculation, 8 plus 4. And children are thinking about that. Maybe this is now year 1 or year 2, so 5, 6, 7 years old. And they're picturing the 8 in their head like this because they've done all of this stuff before. And of course, before they can do it in their head, they need to have done the concrete alongside the abstract, lots and lots. But here they're thinking, well, there's only 2 there, so I can only fit 2 of the 4 on there. So however we do it, we've then filled the 10 and we've got 2 on the next 10. So therefore we've got an 8 plus 4 is a whole 10 and 2 of the next 10. So therefore 1 whole 10, 2 of the next 10, that's why it is 12. And what you're doing there is you think, if you can't understand what the 8 looks like in relation to the 10, you won't have the understanding of how many of the 4 can fit on to finish that group of 10, and therefore that creates your place value because we've finished a group. And that's why we've got that extra column, because we've got 1 whole group and 2 of the next group. And so there's many steps that need to go before that, but I hope that makes sense. So why don't you show 6 with the 5 on the top and the 1 on the bottom? Right, so what I've just said is we'll come to the patterns in a moment. Okay, bear in mind that what I'm trying to do at this stage of the training is give you all the reasons why we need to use 10 frames in a certain way, not the how do you use the 10 frame, because the point that we often miss in our teaching is that we think that our destination is teaching them to use a 10 frame, and it isn't. The destination is how can the 10 frame help them to learn all these things in calculation. All right, so we're starting at the destination and we're working backwards here. So when you have got an understanding of the numbers within 10, the concept images, you will be able to do lots and lots of these things. The next big thing that we're aiming for with number sense is that counting is not the same as calculating. So we have got lots of children further up the school that if you say 8 plus 4, they will do the, in fact, I'll come off again because I need to do a little impression here. You know what they do, you've seen them. They'll go either 8, 9, 10, 11, 12, or they'll go 8, 9, 10, 11, 12, the little head nod. Now that is because they've been taught to calculate by counting. Whereas a child who does this and says 8 plus 4, well, I could add 2 of the 4, and then I would still, that would finish the 10. And of course, this is then what would make sense if you were then using a number line in the future, which again is another step and not, remember, this session isn't about teaching you how to do it, just the whys. So then you would have still 2 of the next 10. So you've got that idea about that child has partitioned a 4 and said, right, well, 4, I've got 2 spaces still on the 10 frame, so I've got to finish that 10 with 2 of them, and then I'll have the other 2 of the 4. That is partitioning, and that is using subitizing, that is using your knowledge of the concept image of the whole number and not breaking it up by doing counting. Hugely important in order to gain fluency. Okay, so let's do a few more and then we will break these. Yeah, so someone's saying their 14-year-old still head nods. A lot of adults still head nod, and the crazy thing is, certainly in the English curriculum and most curricula around the world, you are taught as practitioners to teach children to count on and count back for calculation when they're 5, 6 and 7. And then the very same curriculum, certainly in the UK and particularly in England, from 7 onwards says, get them to use their number bonds. They shouldn't be counting. And you're like, hang on, we just spent the last 3 years teaching them to calculate by count. Of course they're going to calculate by counting. If you don't want them to calculate by counting, because calculation is different to counting, we need to teach them to use the 10 frames right from the start. This idea here that when numbers are cardinal, as in when they are the how manyness of a number, they're made up of other numbers. So you can partition them just like I did with the 4 there. I'm going to reveal all of this now because there's not a lot left, and then we'll come to the bit that some of you are asking about, which is the thing that I do most work on and the reason why I wanted to run the session tonight. So the idea that 5, there are 2 units of 5 within 10, and 5 is an amazing benchmark to understand how to calculate with fluency way beyond primary, not even just early years and key stage 1, so 5, 6 and 7s, but for the rest of your life basically. So if I go back to showing you again, if we think about just having, if we look here, a 10 being made up of 2 5s, when you understand that there are 2 units of 5 within 10, then if you are adding something like 0.7 and 0.5, you can visualize the idea there that that 7 is made up of a 5 and a 2, and use that to calculate even things like, I say, far more complex calculations than that, but use it for decimals. And again, I won't go into that now, but if you're teaching Key Stage 2, you're using your 10 frame to do that if you're doing it really efficiently. Okay, so what I'm going to do now is show you the patterning and get into some of these issues and the reason why I was running this session. So to recap, what I've looked at so far is we need to start not by we need to teach them 10 frames or we need to teach them 5 frames, because there's no point in that. The analogy I often use is saying, you know, I need to learn to chop onions. And you're like, no, you don't. You need to make a risotto, or you need to make a tomato sauce, or you need to make something that has chopped onions in it. And there's another one excuse the analogies, but there's like a joke where someone says a man walks into a shop and says, I need a drill. And the guy says, you don't need a drill, you need a hole in a wall. You know, the drill is pointless. It's the hole in the wall he wants. So the drill is going to enable him to get there. So it's exactly the same with a 10 frame. Never think we are teaching our children to use 10 frames. You are teaching them the things that I have shown you on here. You are teaching them that our number system is about base 10. You are teaching them unitizing. You are teaching them about parts and wholes and the fact that the number system is incredibly easy when we understand base 10. And most of us were not taught that. You're teaching them to be able to add, subtract, divide, multiply, work with fractions. You're teaching them not to count but calculate, and so forth. So can you all see there that the reason I've shown you all of that is because now we can start to get into the nitty-gritty of why does this tool do all that stuff so well, and what must we avoid doing? So my statement that you signed up for was that most of our schemes are getting this wrong, which is really worrying, because the most important thing if you're going to write a maths scheme is your own maths subject knowledge, and there's something, as I say, there big discussions need to be had. So the first thing I'm going to look at is the 2 patterns. Okay, so some of you were asking about that. Right, first of all, you always just meet a 5 frame. So that's just going to be the top bit. Okay, so all of our youngest children and any child who has not been on this journey yet. So my practitioners that work with me, we start children in nursery, 3 and 4 year olds doing this. But if we meet children that are 4 and 5 or 5 and 6 that haven't done this before, they also start with 5 frames, because that 5 is such an important benchmark on the way to 10. So the first pattern we learn, therefore, is what we call the 5s pattern, because you've only got one 5 frame, so you haven't got an option. And what we do, I'm going to show you on a different board here. We have 2 skills running side by side, and I'm going to show you a webinar you can go to see a little bit more about this. But we have subitizing, where we will be looking at 1, for example, and it won't just be 1 counter. It could be 1 stone, it could be 1 flower, and we're learning to recognize, well, they know what 1 is, they just haven't got a word for it. Children from birth know that that amount is more than that amount, but they haven't got words for it yet, of course. You don't need to use a word to understand what something is. But they learn to call, for example, this 2, this 1, this 3, this 1, a 2 and a 1 in 3, and so forth. And again, I do a lot of training on this, so I'm not going into that now. But the idea here then is we've started to recognize amounts. So if I get another one here, let's have a look. So we can recognize a 1, we can recognize a 2, we could recognize a 3, and then we start looking at what that would look like on a 5 frame. So as I say, for the sake of tonight, just ignore that bit there. So a 1 on a 5 frame. Now the only variation here is you could start at this end, because in different parts of the world we are taught to read from right to left, left to right. So that kind of makes sense. And again, I'll talk about orientation in a minute. Don't put it here, don't put it here, don't put it here, because what we are not trying to do is understand what you can do with 1, or probably not a very good example with 1. When we get to say 3, you'll see it more, because you can do a lot with 3, but the 10 frame is not the place to experiment with that. What we are aiming to do is give our children a really clear image in their mind of what a number looks like, and we're going to give them 2 options for good reason. So there's the 1, a 2, if I'm following it like this, it's got to go next to it, because we're trying to create an image in relation to the rest of the 5 frame. So of course it could be over there, but it's got to go next to it, because we want to create this clear image in their mind. So I'm going to stick to this side. It could, your 5 frame, and when we do this, when we do our self-registration, everyone's done training with me, we also do it vertically as well, once the children have got the idea, because mathematically it makes no difference to have it horizontally or vertically. In fact, it's really good to have that variation. So I say ignore what else is going on there. So that's what a 3 would look like. So what do you begin to notice about a 3 on a 5 frame? And because your children are doing subitizing at the same time, what you'll find, and what our 3-year-olds are able to tell us in the training that I've done, is that there are 2 spaces left, or it's not full yet. Or they might show us with their fingers that there's 2. And they definitely do all of that before they say there's 2. They can see there's 2, they just might not have the language yet. And then we look at what 4 looks like. So what do you notice there about 4 on a 5 frame? The idea that it's nearly full, that there's just a space for 1 more. Now, what is really important is we don't do this with 4, and we don't do this. And with 3, we don't do things like this. Because what's happening when schemes or videos online are showing you that is they're confusing the idea that we need to explore what's in 3. We do, but not on a 10 frame, because a 10 frame isn't for that. A 10 frame is to create clear images of numbers in relation to finished units. Okay, so if I take my 3 here, we want our children, we call it move it to prove it, to find that there's a 2 and a 1 in 3, and there's a 1 and a 1 and a 1, and you do that away from the 10 frame. And then you do this with stones, and you do it with big things and little things, and you do it outside and you do it inside. But the 10 frame is not the place to do that, because the 10 frame is a tool to understand base 10. That's what it's aiming for, and that's what we want to give them. So we do this. By the time we have, and again, there's lots more training that I'm not going into here, so if you've got lots and lots of questions, that's a really good thing. Can you see that if that was a 5 frame, that one is now finished? And what we do in our self-registration course is we don't stick another 5 frame to that 5 frame yet. We just have a completely new 5 frame separately, and we start to fill that one up. So we do a lot of work with 5 frames that there's not much on it. There's quite a lot on it. It's nearly full. And the children start to recognize the relationship of finished units and part finished units. So tell me if that makes sense so far. And we've got lots and lots of what I'll call my impact members that are on the call tonight, who've done lots and lots of training and are very, very expert in this. So you can, always ask in the group for anybody who's done more of this. We've also got people who are what's called team impact, which is when you come and train with me as a big group. So they, again, are very expert in this. If you've got a question, I'm going to pause as well just to give you some time. Put a capital Q, I forgot to say that, put a capital Q at the start. And if you've already put one in, can you copy it, whack it back in the text box, the chat box for me with a capital Q, because it's easy for me to see then. So instead of number bonds to 5, focus on 5 frames instead, says somebody. Okay, so yes, to begin with, absolutely, because there's so much you need to understand. I personally, I always do numbers 1 to 3 first, and say there's lots and lots of training to help you break down, because I'm doing about 10 hours of training minimum in 1 hour here. So I say bear that in mind. But say if we started off with bonds of 3, I would also not think about bonds, but think about number facts, because the danger with bonds is we only break partition numbers into 2 parts. And that, of course, is really problematic if you're working with this number. And again, you know, say there's lots and lots and lots of things to share here. But if you're working with that number and you think about if you've only ever learned to split numbers into 2 groups, you're never going to understand that 6 can go into 3 2s. And of course, this is thirds, and further up the school, 2/3 is going to be equal to 4, and so forth. So be really careful. There's so much of the cherry models out there in our schemes that only get us to partition numbers into 2 groups. And bonds, which is 2 groups, is really important. But numbers, all numbers can be split in, you know, indefinitely. Sort of, you know, there's no limit to them. But when we're dealing with whole numbers, for example, here, what's inside a 3? Well, a 1 and a 1 and a 1. What else is inside a 3? Well, a 2 and a 1, and we move it to prove it, or we could have 1 group of 3. So I'd be doing that, and then if you want to use your 10 frame to look at number bonds or number facts, see if it's still true. Is there still a 1 and a 1 and a 1? Is there still a 2 and a 1? Is there still 1 group of 3? It's harder to see on here because the 10 frame isn't designed for you to see that. It's still true, but the place to explore this is subitizing and physically moving these around, yeah, and changing what you do. As I say, you know, use stones, use shells, long as the cognitive load is low, and I'll come to that in a moment. So that is our patterning up to 5. And then once we've got beyond 5 and we're going to add another one, we can start another group of 5. So we can carry on like this, and we can look at a number like this. Imagine we don't know what this is called, but what can we see about it? So the idea that it's a finished group of 5, but this group of 5 isn't finished yet. There's just 2. There's still 3 spaces. And that image of 7 in time, can you see how clear that 4 is as well? The idea that within 7 there's a 4 and a 3, and 7 is made up of a 5 and a 2. In time, look at how useful that is. If you're asked to double 7, and it's just one of the 2 images that I'm going to encourage you to give your children, but have a look there. And if we were doing this as training, I'd be saying to you, what do you see? And I'd also, if I was doing this with children, I'd actually have these on 5 frames that we could move around. I'm holding it like this just for the sake of this training. But can you see, you could take that 5 frame and that 5 frame and move them together, and you'd create a finished 10, and take that 5 frame and that 5 frame, and you'd end up with the 2 2s. So you'd have 1 finished 10 and 2 2s on here, so 4. So therefore 2 7s are 14. Now, as an adult, until you've got that fact, you know, fluent, and of course a lot of adults know 2 7s are 14, but actually if you said, well, but why are 2 7s 14? They'd just be like, because they are. And if you break it down, you often even get adults going 7, 8, 9, 10 and so forth. And you think actually the idea that 2 7s equal 14 because you've taken the 2 5s out to create a 10 and the 2 2s out to create a 4. So you've got a finished 10 and 4 of the next 10. Works with near doubles as well. So there again, think about the 2 5s giving you the 10 and the 3 and the 2 giving you the 5. So everything we're teaching in the early years is giving me the ability to do this when I'm older. So if any questions about, lots of things. Okay, I think ideally, right, so somebody's answering something. Right, cognitive load, I'll come to that, great question. Magnetic whiteboards, Andrea, literally, these were like £1 from the pound shop. There's just so many, you know, basically you don't need a magnetic whiteboard, you just need something metallic, and then get your normal counters and stick a little bit of magnetic tape on the back. So if you go to lots of places online, literally magnetic tape and a reel, has a sticky back on it, cut bits off. As I say, when we do more training together, you'll see me do this. I use like washers and all sorts, and I stick little bits of magnetic tape. So you only need, you know, a metal surface rather than magnetic. Okay, let's, right, how do you work out how many children are in your class or nursery? We have 31, so we fill we fill 3 10 frames and 1 on the next. Okay, so that is a great question, and the best way for me to answer that would be to make the self-registration webinar available to you to buy and watch, okay? Because what we do is we as adults are obsessed with the how manyness. So there's 31 children. The children are not interested in that, because the 31 written down, 2 digits, why would 2 digits represent all of these children? Why would a 3 and a 1, when 3 is what, you know, if you're in nursery, that's my age, that's what they're thinking. What they're interested in is who's there and who isn't. So what we focus on instead is we have photographs of the children and we put them on the 5 frames, and the children are noticing when a 5 frame is part full or full with the little photographs of the children, and we get another 5 frame and we get another 5 frame. And then any pictures that are left in the basket are children who aren't here today. And we don't go down the road of trying to add the 5s together or using the 10s, because that's adults thinking we need to know how many children are here today. And you stop and think, hang on a minute, we're working towards that, but understanding what 31 is mathematically takes on a huge amount of skills in terms of understanding the 3 finished 10s and the 1 of the next 10. And you will get there, but get there by focusing on 5 frames that are part full, and move away from that how manyness. That is something a lot of my members, we had to have a massive mindset shift, and then they were like, actually, yeah, this makes a lot of sense. So I hope that helps, and there's training available that I can share with you. Okay, so right, so I'm going to carry on with this then, and if I've missed anything, I'll have a good look through, and don't forget I can see your comments on the group afterwards underneath this. So we've moved on to our second 10 frame. Now the fact that we've got a second 10 frame means we can explore our second pattern now. And this was the 5s pattern, and the next pattern I'm going to explore is the 2s pattern. Okay, so first of all, I wouldn't call it the pairs pattern, which is called that by some approaches. Pairs also means a type of fruit, and also a pair, you have to understand that a pair is 2 things. But when you talk about a pair of pants or a pair of trousers, it's not that obvious that it's 2 things, because it's 1 thing. So the whole idea of a pair is really quite difficult. If we're calling that the 5s pattern, which I think the same schemes do, I would call that one the 2s pattern, because it's in 2s. You know, it's just one less thing to process, isn't it? The children will call it the pairs, but they're kind of like the bit of lost in translation, particularly if English isn't your first language, which is many, if not most, of our children. So this time, I'm going to find out, for example, I've got this many. If I put it on here, what does it look like if I do the 2s pattern? So I filled a 2, then I filled another 2. And what's really important here again is that we change the orientation. So sorry about all that bit, I'll try and ignore that bit. So you look here and you think we filled it this way. Okay, and again, there's more training that I'll do on this, but it's get the children secure with one orientation and then start to vary that. And I say there's very easy ways to do this. So I'm doing this. So what starts to happen is I learn to recognize a 6 this way. And also, if I take them all off again, let's use the same amount of counters, but let's put them on using the 5s pattern. So a 6 can look like this. So if you think, what properties of 6 is that pattern, you know, making you pay attention to? That idea that 6 is got a whole 5 in it and then one of the next 5. And look at its picture that it makes. Whereas, take them all off, same amount of counters. Look how different that image is. But what does that image allow you to pay attention to in terms of properties of 6? And you think not only does it allow you to see the 2 3s, the 3 2s, there's a 4 and 2 more. You know that is a very strong image to learn about even numbers as opposed to odd numbers as well. So having those two images, that one is particularly good for doubling. You could double with that one. Yeah, that one is particularly good for seeing 2 groups of 3 and 3 groups of 2, for example, and 6 groups of 1. Now they're all still there. There's still 2 groups of 3 there and 3 groups of 2 and 6 ones, but it's not very obvious because of the arrangement. So getting children to switch between them, which is what they all can do given time, they'll all start off with the 5's image, and then we'll introduce, let's say, the 2's images. So I do a lot of work in the Teaching Essential Number Sense training with games where your children are creating these images in their head. And the biggest deal, I'm just going to grab my pen. What we're aiming for here, which I didn't write on my list, is that when your children see something like this, that they don't, when they hear 6 or see the digit 6, picture this, which is what most adults and children do. They picture either this or this. So when you then say double 6, so 6 plus 6, or we could do 6 multiplied by 2, they are picturing the 6 on a 10 frame, and they're thinking, I've got a 6 and I've got another 6, like what could I do with that? And of course this would have been built up using those concrete resources. You don't suddenly chuck the concrete resources out. But what we're aiming to do, I wish we'd had this, is that your children have got such strong concept images. They're thinking, should I do 2 6's that way, which would still work, or should I do 2 6's that way? And I say, oh, so I got the 2 5's, and then I got the 2 1's. So the 2 5's made a whole 10, a finished 10. So if I write that down, a whole 10, and then I got the 2 1's, so there was 2 on the next 10. And that number in English only is called 12. That number is written the same way across the world. Even there are different number systems in the world, but the universal one we all now use is written in exactly the same way. It's a shared language. So can you see, I'm just going to see if I've got any questions. Yeah, so Tony's one of my Impact members, saying that her children, now I think, Tony, I'm right in thinking you're reception, aren't you? So 4 and 5-year-olds can see doubles. They can literally see those doubles in their head. Imagine as well, God, honestly, I could keep you on here for hours. My Impact members will tell you. Can you see in there, can you see that there's 2 4's in an 8? And there's more than one way of seeing it. You might be seeing the 4's like this, or you might be seeing the 4's like this, and both ways is right. You can see the groups of 2 within the 8. So it makes sense about when we multiply groups of 2, and of course we can, you don't need 2-sided counters, and they're very expensive, so don't get obsessed about that. If you see me doing this, mine are very tatty. But this idea about multiplying groups of 2, that shows the 2's, but can you see we've kind of lost the 8? The relationship with 10 helps, but the nice thing about keeping them the same colour, and this is where I'll go into cognitive load now, is the cognitive load now has reduced. When I had them 2 colours, your brain's thinking, whoa, purple and orange. And maybe that's helpful to see those 2's, but when it's all purple, your brain relaxes because there's only one thing to pay attention to. And one of the reasons I use circular counters is because a circle has the lowest cognitive load because it hasn't got sides. There isn't very much to pay attention to, and I personally wouldn't use ones with squirrely patterns on like mine. I'd use plain ones because it allows your brain to see the pattern really clearly. It allows your brain to see what we call negative space, which is stuff that isn't there yet. Can you see if you play Let's All Rearrange the 8 on the 10 frame in weird and wonderful ways, that there is no point? Because the whole point of looking at 8 on a 10 frame is to see the 2 images that you're going to use to calculate. Is there a point in pulling 8 apart for subitizing? Because actually a 10 frame is using subitizing because we're looking at instantly recognizing an amount. But here's 8. Maybe we start off with it in a familiar pattern. And you can see that without the 10 frame, it is harder to see that that's 8. As I say, 8 and 6 look pretty similar. So right there, going a bit out of focus. It's not your eyes, it's my camera. But imagine here we could go, oh look, I found the 2's in 8, or I found a 4 and a 2 and a 2, or I found a 1 and a 1 and a 1 and a 1 and a 4. So this is the place to pull 8 apart. And then when you've got 8 here, you can still find some of those things. You can find all of those things, of course. You can find the 8 ones. You can find I've got a 3 and a 1 and a 1 and a 3. Not quite sure why you'd want to do that on a 10 frame, but it's still there because the properties, of course, of the number don't change. Does White Rose use the 10 frame correctly? Somebody says, well, you'll have to take what I'm saying here and go and have a look. So you'd have to ask yourself the questions from tonight of, does White Rose teach the 5 and the 2 patterns? Does it teach children, one thing I haven't come to yet, you will have noticed you must never count on a 10 frame, so therefore you have to have really strong subitizing first. Lots of reasons for that, but if you're counting like this, 1, 2, 3, 4, you'll tend to think that that one is the number 4, not the whole thing. It's only when you can subitize that you understand the whole thing is 4. Even if children say there's 4, it's usually because they've learned to repeat the last number in the count. So what we do, again, lots more training involved in this, but we get the children to sing a little song when they're filling in the 10 frame, because the 10 frame means that you don't need to count apart from anything else. You know it's 4 because it's the number where there's 1 missing on the 5 frame. You know it's 4 because it's the number with 2 2's in it. It's the number that creates that pattern. And what we are aiming to do is create calculators, not counters. So again, I would suspect, knowing what I know about White Rose, there isn't nearly enough on subitizing underpinning it. There isn't the subject knowledge for the practitioner about how does a 10 frame work, what is it for, how to use 5 frames first. That's missing in most schemes. So that person who asked that, make sure, let's go back to our things here, you need to, whether you're using White Rose or something else, you have to be a user, not a follower, which means you have to ask yourself, where am I getting my subject knowledge from? Where am I getting my pedagogical understanding from? Okay, so let's have a look here. Here are some issues that I've listed. So when we start with, and I've done all of these things, even on my very short journey. I've only been using 5 and 10 frames for about 10 years. And in my early part of my life as a teacher, I didn't have a clue what these things were, so I had to learn. But until very recently, I would have been looking at a 5 frame and looking at, this is what 3 looks like, this is what 2 looks like. I don't advocate that now. We start with the idea about when something has got just some on and it's full and it's not full. And young children are very, very interested in that. Is there enough space for me to put mine on yet? The idea of one thing per cell. So you've seen on there, we never put more than one thing in each cell because we're trying to create an image of a number. It's as simple as that. So an issue is counting. I haven't seen any scheme address the fact that there's no point in counting on a 10 frame. You are making the 10 frame redundant if you're counting. Same for a 5 frame. Cognitive load is really important. I'm going to illustrate this. So, got a couple of issues here. Right, cognitive load. Let's have a look at this image here. Is a good example of it. And we talk about this in the group all the time. Right, cognitive load is how much processing your brain has to do. So most schemes are really guilty of this. They think, let's make maths interesting. So let's use butterflies and wellies, and I think that's a fawn, and eggs in a basket. I'm not sure you're supposed to be thinking about the eggs or the baskets here. Watering cans. So the children are looking at, and the adults are looking at the thing and not being allowed to see the pattern that it makes. So if you've got anything like this, if you then put, I mean, that one's particularly bad because I think that looks like 3 things, doesn't it? But imagine, I think these are hats or something, but if you put a counter on each of these, you can then transfer the counter onto the 10 frame. And what you've done is you're showing that the hat can be represented by a counter, and it allows the children to see the pattern much more easily. But ultimately we want our children to know there are 3 butterflies there, and to know because they say, well, I can see a 2 and a 1, because that's a much stronger skill than using counting. And I do talk about when to use counting and when not in the training. We want our children here to think, well, I know that's a 5 because there's a 3 and a 2, and that one's only a 4, so it must be a 9. That's what we're aiming for, but they're not going to be able to do that for a really long time. We need to create those concept images on the 10 frame first, and that takes months and months and months, and even years and years to do well. So cognitive load, the way that I explain it is, if I come back, hang on, back on the screen again, excuse me a minute. With man-made things, they should be exactly the same size, shape, colour. So my counters are all identical. So if you're using buttons, exactly the same size, shape and colour. If you're using washers, as in, you know, little metal things, same size, shape, colour, identical. Because then the brain notices the patterns, notices the maths. When you're using natural things, because Mother Nature is has a bit more variety, but the brain generally likes looking at natural things, so you have lower cognitive load anyway, more relaxed. If you're using stones, similar colour, similar size, similar shape. Same with shells, same with leaves. What you don't want to do is create lots and lots of interest. Do that at a separate time. If you want your children to notice leaves and notice colours and stuff, that is such a beautiful activity, but it's not the best way to teach patterns on a 10 frame. So do your noticing of leaves as an activity for language and curiosity. But if you want to know how many leaves you've got, use leaves that are very, very similar, because then the children will see the mathematics that you are creating. I hope that makes sense. Yeah, so Katie, the people talking about songs. So Katie, an Impact member there, yeah, you can literally use a song that you know your children know to start with. Just make sure it isn't a song that has a kind of counting element. So for example, like the ABC song, because then you'll still create this kind of sense of counting. Just a little song that they can just switch on and off, and it won't drive you too mad. It sounds a bit bonkers, but you've seen me doing this tonight. I'm chatting away, so you know I'm not counting. And I'm going to say, I know that's 8. And the reason I know it's 8, there's loads of reasons. Well, there's 2 not there yet. I know that about 8. I can see a 4 and a 4. I know that about 8. You are really, when you are doing that, when you move away from the idea of counting, you will begin to calculate, because you can see the parts within the whole. You can see the relationship within 10. Okay, so I will come back to the chat box again. I think there's lots and lots of things, and I'll make sure I show you this because we're out of time now. I hope you can see, without me explaining too much, the problems with these things. This one, cognitive load, and the pattern. There's no point in this. If you want a child to see 4, then use the 5s pattern, which would be, you know, a 5 with 1 missing, and the 2s pattern. And don't use these things too soon, because they're much more interested in the wild animals than the maths. There's a time to look at the wild animals, but it's not on a 10 frame. But ultimately, the tool you're giving them will enable them to see that there are 4 wild animals there, but that will be much further down the line. This one, I actually took the idea for my washable 10 frames from this blog, because it's a great idea. Make them. There's a video of me making them on my YouTube channel, but this is not mathematically accurate. This idea about having 2 here and 3 here, it should just be 1 thing per cell. So can you see that it's not a Karen said, it's what is the maths we're aiming for? Okay, so you will see things that say, oh, just let the children explore in whatever way they like. If you want to let them freely play with these things in their own way during continual provision, that's absolutely fine. You can do whatever you like, but this has been steered by an adult. You can see that. That's what children would do on this in terms of their play would be very, very different. And again, I say if there's more questions about that, I can answer them. This, can you see, this is a complete misunderstanding of what a 10 frame's for. Can you make collections of 1 thing, 2 things, 3 things, 4 things? Of course you can. Absolutely. Do that till your heart's, your heart's content, but don't misunderstand what a 10 frame's for, because a 10 frame is this incredibly powerful, tool for you to use and teach. Okay, so we're coming to the end. Let's have a look. I'm going to apologise straight away if I've missed any big questions, but the fact that we've got it on the group here means I can go through these and look and make sure that I answer. Just before we stop, because I'm going to show you a couple of places you can go to find out a bit more, I want you to come away from this training, if you're not someone who's done a lot of training with me already, and think, I'm hoping, as I say, that you're going, but what about this? But what about counting? But what about my scheme? But what about what my SLT says, my senior leaders? But what about my, team members who don't understand any of this? That is exactly where I started, and that is exactly where all my members started, and that is exactly where all schools that work with me and practitioners that work with me start. And it's a really good place to be. Because what I want you to get out of tonight more than anything is you think, this is not about do it the way so-and-so says. This is about what is the maths that we are aiming for. And I hope you've seen tonight that what we are doing as early years practitioners is about the success of these mathematicians when they are 7 and 9 and 11 and 45 and 60 and whatever age, because the base 10 system underpins all calculation. Really important. So one thing I'm going to very quickly show you, because my members love this and it blew their mind, is, in fact, I'll do it in 2 colours. My husband will tell me off because I said I'd be off at 8:30. Right, okay. 8 times table. Everyone's favourite, yeah? All right. No, I know. Right, here we are, multiplying 8s. Show this to your Key Stage 2 teachers. So we could have another 8 here. I'll put another 8 on when I'm chatting. So we are going to join this 8 to this 8. And you can see, even before I do it, hang on a minute, let's hope I've got enough. It's very wobbly. Right, so we've got 3 8s we're going to multiply here. So you can see that 2 of these can fit onto there, and we're going to be left with 6 on here. So I'll do it now like this. Okay, now can you see we've got a gap of 4? So 4 of these can go on there and 4 of these will be left here. So we've got 8, and then the reason we've got 16, 1 8, and that 8's been split like that, is because 8 is 2 fewer than 10. So it was always, so can you see the pattern is moving back? We've got 8, then 6, and then we had 4 spaces and another 4 spaces, so the next pattern was 4, so it's the final digit, so 8, then 16, then 24. Can you see if I put another 8 on, we could put 6 of the 8 here, and 2 would have to go here, so it would go 8, 16, 24, 32. And the next one, you'd have a whole big 8 space, so that's why it would go to 40. That is your early years teaching being used to teach the 8 times table. So I'm hoping that is a good place for us to finish. So I'm just going to show you, before I scoot off and have my tea, this is the website. Go to Learn with EYMaths if you want to know more about training that is instantly available to you. And you can message me and ask me whatever you like. And the other place, I know I was going to do this, is my YouTube channel, which I know Katie and a few others have mentioned tonight. Can you see here an introduction to 5 and 10 frames? Look, there I am. Have a look there. You've also got making your own outdoor 10 frame here. There is all sorts of little gems here from across the years for me to share here with you, but come and dip in. But I would definitely look at this one after tonight. And again, as I say, if you've got questions, I am always here for you. And what is even better than having me is there are so many people on this group that have done such a lot of training with me. They have an incredible wealth of real knowledge. In this group, we don't say, can you send me your planning on? We say, can you help me understand how to plan this? That's what we're about. So I really hope that hasn't been too much of a whiz through, because I hope that if you're brand new to me, you've gone, oh my goodness, this makes so much sense. But I want you to have the mindset that being on this journey, you are going to make the biggest difference to yourself and therefore to every child that you ever teach. It's not a new way to teach maths. Maths hasn't changed. We haven't been teaching it very well, is the reality, and that's because we didn't have the right tools. All right. So take care, everyone, and I will do more sessions like this. So make sure you keep an eye on your email, keep an eye on the group, give me feedback about what you've got from this. We call them wow bombs, things that you go, Do you know, this makes so much sense, but I hadn't thought about it like this before. All right, take care, everybody. Have a great evening, afternoon, whatever time of the day it is with you, and I will see you soon.